Hey guys, Assalamu alaikum. My name is Electron and today I'm going to show you the effect of a potential difference on an electron if it's allowed a path to flow down. What was that about? So in this video we're going to be learning about this thing called voltage, right? And more specifically we're going to be learning about the voltage across different electrical components known as potential difference. So voltage is the amount of work done or the amount of energy that is transferred per unit electrical charge, and obviously we know that the unit of electrical charge is the coulomb, right? So the work done or the energy that's transferred to each unit of electrical charge, so per coulomb of electrical charge, so that it can move from one location to another. That's voltage, right? And if we're specifically talking about the voltage or the energy consumed or the energy transferred per unit charge to get across a specific component, for example, a resistor, a bulb, or a motor, for example, things like that. So we're talking about a potential difference, right? So as long as it's in a part of a circuit, we're talking about potential difference. So mathematically, voltage can be calculated as voltage or potential difference if it's in the case of a specific component. So voltage is equal to the work done in joules, of course, per unit charge. Right, and the unit charge is of course in coulombs. Voltage, potential difference, is measured in volts. So that's just a capital V, volts. And work done, the energy that is transferred per unit charge, right? So work done is in joules, and the charge would be in coulombs, a capital C. So let me try and explain what I was demonstrating in the previous video, right? So here I am on the slide. Oops, hang on. So happily about to slide down that slope, right? I've got some stored energy because of my height above the ground, right? So that stored energy is known as potential energy. Specifically, it's the gravitational potential energy, calculated as mass in kilograms times the acceleration due to gravity, 10 meters per second squared, times the height in meters, right? So I had some potential energy, some stored energy, and there was a potential difference due to my height above the ground, right? So that potential difference was the source or the cause of me being able to slide down, right? So that was basically, that potential difference was the energy I gained, the kinetic energy, motion, right? So the motion I gained, the kinetic energy that I gained in order to be able to slide down. So there's my kinetic energy. So gravitational potential energy, the difference of which that's being transferred into kinetic energy, so I'm able to move. Well, the same sort of concept happens when we talk in terms of a cell as well, right? So a cell, a battery, etc. So when we've got a component, so for example, we've got a light bulb, well, there's an excess of stored energy. This time it's not gravitational stored energy, it's not gravitational potential energy, we're talking about chemical potential energy. So we've got energy stored in the form of a chemical stored energy, chemical potential energy, right? And there's a difference in the amount of chemical stored energy, and I'm not going to get into details, but that energy is supplied using the cell, right, or the battery, and so because of that potential difference, the difference between the chemical stored energy on one side of the cell, of the bulb, sorry, and the energy on the other side of the bulb. So some of that energy, just like before, gets transformed into a type of motion, right? So a type of kinetic energy, but we don't call it kinetic energy because we're not talking about an individual particle. That would be kinetic energy. We're talking about them as a whole, right? So when we're talking about them, as a whole, we're talking about the electrical energy that they gain, right? So that's the difference in potential, and that's the energy conversion that is taking place. Now, with that change in energy, the type of energy, we've got electrical energy, so some of the electrons in this case would be able to flow through the bulb and deliver some energy to it, right? So the amount of energy that is delivered per coulomb of charge is known as the voltage. So the amount of energy that is delivered per coulomb of charge is known as the voltage, or the potential difference, because this is a specific component within a large circuit, right? So we're not talking about the entire circuit in this case. We're just talking about one specific component, like a bulb, like an LED, like a thermistor, like a resistor, and so on, right? So voltage is equal to the amount of energy that is transferred per coulomb of charge. So the greater the amount of energy you have per unit charge, so the more the number of joules you have per unit charge, the greater the potential difference is going to be. So there's a chemical imbalance that is creating that potential difference, which is causing the electrons to be able to flow through that voltage, right? So evidently there's going to be an excess of electrons on the one side, and there's going to be a deficiency of electrons on the other side, right? So the side that has an excess of electrons is said to be at a negative potential, and the side that has a deficiency of electrons is said to have a positive potential, right? And we say that the conventional current flows from the positive potential down to the negative potential, whereas the electron flow is in the opposite direction, from the negative potential to the positive potential. So you might be wondering, hang on, shouldn't the amount of energy you have per unit charge, the voltage per, the work done, sorry, per unit charge, shouldn't that have something to do with the flow rate of those electrical charges, meaning the electrical current, so charges that are flowing per unit time? Well, you'd be right in thinking that way, because there is something to do with that, and that has something to do with something known as Ohm's law, right? So Ohm's law, which we're going to study in the coming videos, but hold your horses, there's something we need to discuss first: resistance, which is coming in the following video. So that's it for this video. Be sure to go through the outcomes in the description below, and